All right, so here we have how long will it take an investment of $10,000 to grow to $15,000 if it's invested at 9% compounded continuously? All right, so what do we know? We're doing continuous compounding again. So again, remember A equals PE to the RT. We know it's going to get to 15,000 and we started at 10,000 and we have 9%. So it's going to 15,000. We started at 10,000 and we're having a 0.09. And what we want to know is how long, and we're going to call that T. So what we need to do is we need to solve this equation for T. So first off, we're going to do it longhand and we'll show you on a calculator. So first off, we'd divide both sides by 10,000. Okay. So now we have, well, if we want to reduce this, we can reduce this. Three of those cancel three of those, and five will go in here twice. Five will go in here 3/2. So we get 3/2 here, and we have e to the 0.09 t. Now, to get this down in front, I need to take the ln of that side. If I take the ln of that side, I take the ln of that side. And remember, when I take the ln, I can bring the exponent down in front. So now I have ln of 3/2 equals 0.09 t ln of v. Now, by natural log definitions, that is equal to 1. So that disappears. Now we solve for t, we divide by 0.09, divide by 0.09. And so t is equal to ln of 1.5 over 9, 0.09, sorry. All right, so we have the ln of 1.5 divided by 0.09. And so t looks to be 4.51 years. Okay, so that's what that is. Now let's go and do this a different way if we forgot how to do our log properties. And we can do that in under math. We'll go up to numeric solver. And on the left side, let's call that our 15,000. On our right side, we had 10,000, and then it was e to the 0.09, and then we had a t, but in this case, we're going to use x. Okay, so now we just have to OK, which is the graph, and we can guess 25. It doesn't matter what we guess, and we get 4.51. So a lot quicker, but this way, we can't actually write anything down. And if we typed anything wrong in here, we won't know for sure. So either way we do that, we get t is equal to 4.51 years. So that's how long it's going to take to go from 10,000 to 15,000 compounded continuously at 9% interest. All right, so how long will it take money to triple if it's invested at 5.5% compounded continuously? All right, so now we have to think about this. We're starting with some principal, and we're going to triple the value. So that's going to be equal to 3 times as much, right? And that here, this 3p, that's what our future value is. So what we could do is we could say, okay, well, 3p is equal to p, and then it's times e to the 0.55, and again, we have a t, okay? Now, if we want to solve for t, let's divide both sides by p. Well, guess what? That p cancels that p cancels that p, so it gets 3 equals e to the 0.055 t. Okay, so now we've got a pretty easy equation. Well, now what we can do is we can do like we did last time, take the ln of both sides, and then that will come down in front here. So now we have ln of 3 equals 0.055 t ln of v. Remember that's 1, divide by 0.055. And so t is equal to what? All right, well, if we plug that over here, get out of here. And so we have the ln of 3 divided by 0.055, and we get 19.97 years. Now, there really isn't an easier way to do this one because, again, we're plugging in p's and stuff, so you have to divide that out. And so at this point, really, you might as well just continue on with your log functions and simplify yourself. So again, that was 19.97 years. That's how long it's going to take to triple our money if we invest it at 5.5% compounded continuously. All right, so that's the main kinds of problems we'll see in this section. So hopefully that will help you.